right, let's get with it. My name is Kerry Bruce, and today I'll be talking to you about integrating the Raspberry Pi into computer information systems or computer science programs. I'd like to welcome you and thank you for joining me for this presentation, the last presentation of the conference on a Friday afternoon, except for the fact that we're going to do a live Raspberry Pi lab shortly after this. So hopefully you have time to join us for that. It'll be a couple hours of fun building something on a Raspberry Pi. We haven't decided yet as of this recording, which is way before the time that we're doing the lab. For me, introduction to me. My name is Kerry Bruce. I've got 20 plus years of experience in IT industry. I've been a teacher for the last 8 years. I currently teach at Central New Mexico Community College. And I've been using the Raspberry Pi in the classroom since 2014. Our agenda, which we have to cram into 25 minutes. Why the Raspberry Pi? I want to go over potential uses of the Raspberry Pi. And this will be pretty much a brain dump slash storm of ideas for you to think about as you look to maybe add a Raspberry Pi project or two into your curriculum. I want to cover some common Raspberry Pi configurations and their cost after that, and then we'll kind of wrap up and take a look at some of the resources that I put together for this particular presentation. The key takeaway that I want you to go away with today is I want you to think about what one assignment or project could you change to include a Raspberry Pi in order to enhance your students' engagement in the assignment or project. Okay, so what we're trying to do is, or what we're trying to think about is, what is there an assignment that I have that I already do that maybe we could flip it into and turn it into a Raspberry Pi project where the students get a more physical connection with the project itself. All right. Or could you take a project and add a Raspberry Pi? Add a Raspberry Pi to take sensor inputs or button inputs or LED outputs or something along those lines. All right. That's what we're trying to think about today. So as we go through all this material, I'm going to highlight a lot of things. I'm not going to cover everything that I have in the slides in depth because of the time limit. But I do want you to think about where could you add a Raspberry Pi? Okay. For those of you that aren't familiar with the Raspberry Pi is the computer that's on your screen at this point. It is a credit card size ARM-based computer. It's a single board computer, meaning that the processor has the CPU, the memory, and the video built into the processor, real similar to your cell phone. This particular computer costs $35, which is the first item there, low cost. So the base unit is $35. There are two enhanced units that have more RAM in them currently available that are $55 and $75. They're still really inexpensive when you compare it to a regular computer or laptop. The other thing that's cool about the Raspberry Pi is it's flexible, it's expandable. It's got these GPIO pins, these pins right here, that you don't get in a laptop or a PC. And this allows us to connect physical devices, sensors, actuators. We can create electronic circuits, we can control motors, we can do all kinds of really cool things. We can add what's called HATs, hardware attachments on top, to the unit to add additional functionality to the Raspberry Pi. Right? It's also got Ethernet, it's got Bluetooth, Wi-Fi, it's got the ribbon cable here for cameras, the ribbon cable for display. It's got two HDMI ports capable of pushing out 4K video. Okay, which leads us into power. There's lots of power built into this little box. Right within the specs of a credit card size computer, again, relative to the size, relative to the cost. Right, the cost is only $35 for the base unit. But for the size and the cost, there's quite a bit of power available. Okay. And one of the biggest things about the Raspberry Pi that I like and why you should consider it is that the community around the Raspberry Pi is super helpful. So if there's anything you ever want to do with a Raspberry Pi, you just Google Raspberry Pi supercomputer, Raspberry Pi robotics, Raspberry Pi machine learning, and you'll get hundreds and hundreds of articles, tutorials, videos, all kinds of things where people are showing you how to do that kind of stuff with Raspberry Pi. And then the very last thing that I really think is important, and this is as an instructor, is it provides a tactile learning opportunity. There's always something physical to do with the Raspberry Pi, so there's always a touch component, which I think is super important to the student's learning process. All right. So why should you do this? Low cost. It's affordable to students. Right. Students typically don't have a whole lot of money, so we want to get the most bang for the buck. It's flexible, it's expandable. I can make this thing do all kinds of tricks, and you'll see that shortly. It's really powerful for the size. It's got a great community around it, and there's this physical, tactile touch component that I think is a big deal. For those of you that are, probably around my age, right? Commodore 64, VIC-20, TRS-80, all of those computers required you to learn. There was a touch component, a feel component. You had to connect things and make things work and understand how it worked. And I think a lot of IT folks in my generation, that's where we came from, where you actually had to learn by actually making it work, right? Not just opening a box and plugging things together. Anyways, moving on. This is a resource-heavy presentation. The website you see here is the website, a web page that I created specifically for this. Every single thing that I talk about in the presentation will have a link on this web page so that you can dig into the content more and make up your own mind about it. Right? My goal today is just to share with you what I do and some ideas and some thoughts. Hopefully to inspire you to include Raspberry Pis in your classes. Okay, but yeah, go out, check out the website. If you haven't signed up for the newsletter, sign up to stay informed. And if you get out there and you like what you see and you want to help, reach out to me. So it'd be awesome. All right, moving on. Examples and use cases. So Raspberry Pi and networking. So I teach a Network Plus course, and in that course I have the students build the entire network infrastructure based on Raspberry Pis. Okay, so everything you see there on that second bullet point: DNS, DHCP, wireless access points, network scanners, print servers, file servers, VPNs, firewalls. They build all of that, and a Doom server. We actually played Doom the last 2 weeks of class. If they have the network right. So I reward them with if you built me a really good network, then we get to play Doom. Or something similar. I think last time it was another first-person shooter game, but it was real similar. Anyways, so this class has become like, my students they're kind of mad at me right now because I haven't taught this class in 2 semesters. And there's lots of people that want to take it, but I haven't been on the rotation the last couple of times. But yeah, so we build all these things on a Raspberry Pis, right? So we go out and we research what it's going to take, and they work in groups, and each group they have to work with each other to make this happen. The other cool thing that we do with this class is I use Spiceworks, an online ticketing system to assign the work. So then they actually they get tickets, and they have to fill out the tickets and turn them in order to get credit for the work that they've done. So we're kind of simulating real world with that. From a programming standpoint, right, for those that are teaching computer science or any kind of programming courses, you can see on the left there, massive amount of stuff. And that's not everything. That's just the most popular of all the different languages that you can do. And some that are not popular, like Fortran and COBOL. I just put them on there because I know you can actually do them. You can actually program those on a Raspberry. You have a flexibility in your IDEs, right? Everything from Idle to Visual Studio to Arduino to Jupyter Notebooks. There's all kinds of things in between there. Whatever the student is comfortable with, there's some tutorial out there that will show them how to set that up on a Raspberry Pi. And the last piece that I really like to highlight here is the GPIOs again. Those GPIOs give us access to the physical world, to sensors, to buttons, to potentiometers to turn dials to LEDs to things like that that you wouldn't normally get on a PC or a laptop. So you can integrate those into a program and enhance a program or a project for your students. All right. Using the Raspberry Pi in cybersecurity. Cisco has an IoT fundamental security course. It's really nice. I love that course. We just got done with instructor training here this last fall. But in this course, you explore the device, network, and application vulnerabilities by actually hacking a Raspberry Pi to see the vulnerabilities, right? And then you work towards how do you fix those vulnerabilities. There's also a security game that utilizes Raspberry Pis that's built into the system. It takes a lot of setup, and we're currently working on getting one set up at C&M. So when we get back to actually having live classes again, we'll be able to do the live security game. Additionally, you can have the students set up Kali Linux. You can have them set up network scanning. You can have them build Pineapple Pis. I've had students do man-in-the-middle attacks on a web encrypted network, and shown using Raspberry Pis to show how that process works. So there's lots of things that you can do with the Raspberry Pi inserted into an environment like that. Right, so lots of good stuff in the cybersecurity world. When it comes to cloud computing, right, you've got the big three there in the top left corner: AWS, Azure, and GCP. Additionally, we use MongoDB, IFTTT, Twitter, and Dweet.io in my IoT class. I want to play with Docker in my server classes. I do some Alexa, Amazon Alexa, and Google AI as part of my Hackerspace student group, but those are also really cool things as well. Yeah, so from that standpoint, you can see there's a lot more there, but the plethora of things that you can do, I think this list could probably be 3 times as long if I really wanted to spend another couple hours to look for stuff. So I just want you to be aware of the fact that, hey, if you wanted to really kind of have these students learn how this stuff works, there's a massive amount of opportunities to do that with this $35 device. Web development. So those that are teaching web development, right? Remember, Raspberry Pi runs on Linux. So running a LAMP stack, a Python web server, doing PHP, HTML, WordPress, all of those are kind of everyday run-of-the-mill things that you would do on a Raspberry Pi. They're all easily handled and easily managed. So you can actually turn Raspberry Pis into web servers, right? So if you needed to have web servers for everybody, you could set up a machine and do virtual machines, or you could set up a stack of 10 Raspberry Pis and do the same thing for 1/3 the cost, right? So something to think about. Or students can have their own, and they can build their own web server, and they can take it home with them, work on it, bring it back, show it off, plug it in the network, and show people their cool websites that they built. Raspberry Pi and IoT. So we teach an IoT class. It's part of our network program, our sysadmin program, and our computer support specialist program. What I like about the IoT class, number one, is the very last item there, creativity. I always, by giving them, here's a box of real, parts and pieces, and we're going to make, a twittering photo booth out of this. And then just the idea of thinking beyond the instructions and how do I grab this piece and this piece and this piece and put them together. I think it makes for a stronger IT technician. I came from industry, so when I look at my classes, I'm trying to figure out how do I teach my students things that I really would have loved to have my employees to have, right? The skill sets I want my employees to have. And so this class is what does that for us. We do a lot of kind of soft skill things, the quote unquote soft skill stuff, but project planning and management, presentation skills, teamwork, connecting the divergent systems and working with other people to make that happen. Like lots of really cool stuff that's going on in there. And this class is based on Arduino and Raspberry Pi. That's actually the textbook that they purchase, is those kits. And the idea of this whole thing is if you had students purchase a Raspberry Pi kit during their first semester, and you had multiple classes where they would use this kit throughout their 2 or 3 years with you, right? The kit gets used over and over again, so then they're utilizing this purchase, right, multiple times. So total cost of ownership is minimized. A return on investment is increased, right? There's all these things that you can teach in addition to, by utilizing these devices throughout multiple classes. But in this class, this is, obviously one of my favorite classes out there, because it incorporates a bunch of things that we don't have in other classes. We don't have time in other classes to work on project management and teamwork and some other things as much as we do in this class, right? Additionally, they learn basic electronics, so they learn how things are connected, and that connectivity is important, and plugging things in the right place is important. They learn Python skills, so they can actually write their own scripts. Tons of good stuff that they learn, and it's all based on Raspberry Pis. In computer science, I broke it down into 3 different categories: AI, machine learning, robotics, parallel computing. AI, in the AI world, right? Google AIY, Coral AIY. You can put TensorFlow on a Raspberry Pi. OpenCV for some computer vision stuff. On the robotics side of the house, right? I have a Pi Wars team. I got a Vex robotics team, but we always end up having autonomous robots, which gets us back to machine learning. And then parallel computing, right? So you've got Beowulf clusters, MPI clusters. I've given you, and then there's a couple there, the examples, like Buckeye Pi has so the Ohio State built 128 nodes, Los Alamos National Labs built 750 node Raspberry Pi computers. San Jose State, there's a couple articles in the links about using Raspberry Pis as inexpensive parallel computing components. And again, that's kind of the point that I want to make with this one, is that with Raspberry Pis, I can make a 10 computer cluster for less than $500, and 10 computers has 10 nodes has 40 processors, right? So I can have a 40 processor parallel computer for less than $500, right? Something that students can build and have built. I've had a student build a 22 node supercomputer. We've had students build 3D printers as well using Raspberry Pis. So system admin. So this is kind of my bucket where I live at this point. And we spread out Raspberry Pi projects across a bunch of different classes that I have. But some things to remember, right? It runs Linux, so there's currently about 50 distros available currently that run on the Raspberry Pi. You can do remote administration, right? So teaching them VNC and SSH, KVM. You can have them build servers on the Raspberry Pis. You can have them work on network configurations and network infrastructure. You can have them do network monitoring. I have not done this yet, but virtualization. With the more powerful Pi 4s, this becomes a lot easier to deal with. So there's lots of opportunities there to teach virtual desktops. You can run Kali Linux for system monitoring. Students learn system updates and package management. You have to deal with Wi-Fi, Bluetooth, and Ethernet. So there's lots of opportunities to teach just basic computer skills, basic system admin skills using the Raspberry Pi. And finally, from an idea standpoint, if you wanted to take it up a notch and get into industrial IoT, the first 3 there are companies that actually produce IoT control boards that are based on Raspberry Pis. Okay, they're all based on the compute module, which we'll talk about in the configuration section. So they are a modified version of the Raspberry Pi, but you can see in the bottom corner there, they are built into industrial sized housings that work on DEN bars that allow you to do facility management and control of HVAC and other things using Raspberry Pis. Okay, so you're giving those things a lot more intelligence than you normally would. Wow. And now I get emails. All right, the Raspberry Pi basic configuration. Okay. So I want to go over a handful of ways that you can put these things together and where your students could do these things. So the basic setup, you're just going to buy a real basic Raspberry Pi kit. You can get those from a lot of different places. I've just given you a couple examples. At that point, I tell my students, go either use a spare keyboard, mouse, and monitor, or go find used ones, right? Go to Goodwill, go to thrift stores, go to garage sales, buy a decent one, clean it up, plug it in, and go to town. You don't need anything fancy for this, right? I encourage them to get extra SD cards for backups and using different OSs, so you can change out OSs instead of overwriting your OSs. And then over time, they're going to pick up miscellaneous hats, physical computing components, and some other stuff. Okay. To get started, they're talking about $100, right? And then a decent setup, once they get going and have a couple classes, then maybe $200. And then if they want to add the Pi Top case for ruggedized computing, then they're going to be up in more of that $300 range. So we're looking at an investment of $100 to $200 over the course of 2 or 3 years of schooling. Raspberry Pi just came out with the Raspberry Pi 400. It's this computer right here, so it's harks back to the VIC-20 Commodore 64 days, TI 99 days, where the keyboard and the mouse, keyboard was built into the computer. That is a Raspberry Pi 4 built into a keyboard. Okay, the kit that you're seeing on the top right there is $100, and you would need to add a monitor at that point. That's pretty much all you need. So again, the price is going to be between $100 and $200. If you go, maybe $300 if you get crazy. The one thing I would add is a $5 board that plugs in kind of right here. That allows you to get easier access to the GPIO pins, which are embedded in the back of the keyboard. Okay, so this is another option. I think this is a nice option because you basically have everything with you right there. You just have to have a monitor to plug into, right? And if you have an extra, if they have a monitor on their desk, they probably have an extra port on the monitor that they can plug into and use the Raspberry for their projects. The Pi Top 4. This is the Pi Top 4 right here. This is a ruggedized version of the Pi Top. It's an expensive version of the Pi Top. It's about $200 for that device. You need a keyboard, a mouse, and a monitor at that point still, so that's why it's $250 is the minimum. They do have a robotics kit coming. They also have a clamshell laptop keyboard and touchscreen that are really nice, that you just click the Pi Top 4 into. And then they have this really super nice sensor kit. These are sensor kits they're on little dies, and the dies actually can plug into Lego boards. And then they connect with quick connect cables, so you're not doing individual wiring. So from an ease of use, from a ruggedized standpoint, I'm thinking the reason I put this on there is if you're looking at maybe doing this in a classroom and you were going to buy them for the classroom, I'd probably push you this direction. It's a little more expensive up front, but they'll last a little bit longer. There's no electronics exposed. There's actually fans and everything on the inside, so it keeps it thermally keeps it taken care of, doesn't get too hot. You do have another option. So this option on the cheap is what we're going to do here is we're going to take old desktops, right? If you can get some from your IT department, you can install a desktop Raspberry Pi desktop OS onto the desktops or laptops, and then you would get this $15 Raspberry Pi W. Raspberry Pi Zero W, and you can plug it in with the USB cable, and through the operating system you can access these pins. So you get the same exact tactile deal because you actually have access to the pins, but you would do all your work on your computer or your laptop on an operating system that looks exactly like the operating system on the Raspberry Pi. All right. And then finally, from a configuration standpoint, again, if you wanted to go industrial, these are the compute modules. This is a compute module here, and this is the board, the module, the I/O board for programming the module. There's all kinds of varieties of versions. There's the lowest one is $25. The most expensive one is $90. The I/O board is $35. You can get an antenna. You can embed these into TVs for displays. You can embed these into All those industrial components were all embedded. If you wanted to embed it into an exterior sensor system, you could do that. So these would be, you would do all your prototyping on a regular Raspberry, and then you would have, you would flash these units and have everything run from these embedded units. Right, so lots of really cool opportunities there. There'll be lots of links on how that works in the website afterwards. All right. Want to reiterate real quick, because I know we're running out of time, the reasons that you may want to consider a Raspberry Pi. First of all, it's low cost, so it's affordable to the students. It's flexible, expandable. You can see from all the different use cases and different projects that I've shared with you today, that there's lots of different things that you can do with it, and you can do that in all of those and just kind of switch between classrooms. In fact, if they needed two different projects in two different classrooms, they could actually have an SD card for each class and have them completely different operating systems, completely different set of programming, completely different if they really needed to. The power for the size and the power, right? It's tiny, it's portable, and you get a fully functional desktop computer using the brand new Pi 4s. Okay, the community around the Raspberry Pi is amazing. That is probably the number one reason it should probably be on the top. For me, the tactile learning opportunities where you're doing something physical, I think that helps them remember what it is they're doing. Okay, and then finally, they're just plain fun to work with, right? They're fun to play with. They're fun to do stuff with. When you build a project and it works, you get super excited. You want to share it. People are amazed by all the things that your students are doing. Totally fun stuff. All right, and real quick before we leave, we're going to have a live lab directly after this. At the time of the recording, we had not decided what we were going to do. So I'm not sure. So you'll just have to come and join us as soon as we're done. And if you want to get some hands-on training, I am teaching the IoT Connecting Things course. And starting January, I'm teaching the Big Data course starting in March. Most of the course time that we spend together, we'll be doing labs and walking through them step by step together, working through the problems, getting aware of, learning about the kind of the gotchas and the things and the workarounds and things like that. So the stuff that most instructors are scared of or are worried about, we cover in the live sessions. The focus of those is more on that than the actual content. You can easily read the content anywhere, anytime. But to get to the comfort level, that's what we're going to do, is get you comfortable, right? And then finally, the web page. So this is the web page. It's myitinstructor.com/watsi.html. And what I've done, I got about half the resources posted at this point. So for each section that we talked about today, I will have a complete humongous list of hyperlinks out to any of the topics that we talked about, right? So there will easily be, another 3, 4, 5 hours worth of content that you can dig through to become inspired and hopefully find something that you would like to try in a classroom. If you do, let me know what you're working on, and I'll see if I can do anything to help you. Okay. My contact information is, if you want to catch me on social media, just look for My IT Instructor. Most of them have that as my connection. If you want to email me, Kerry@myitinstructor.com, and obviously I go out to the website, sign up for the newsletter, and stay in touch. Okay. I want to thank you for being here. Join us for the Raspberry Pi workshop that we're about to do here momentarily. And any questions?